China reveals a bold new plan to explore the solar system, while NASA finds something interesting on the planet Mars. Updates are made regarding plans to land on Mars, while Europe's first rocket has an unexpected return to the launch site. China's new plan involves the majority of our solar system, from Venus all the way out to Neptune. Most of this sounds fairly practical, but some of it is downright insane. The Chinese recently created a new entity called the Deep Space Exploration Laboratory, the purpose of which is to strengthen the country's approach to solar system exploration. The laboratory is a partnership between China's National Space Agency and the University of Science and Technology of China. China has been very active in lunar exploration, including the first rover and sample return from the lunar far side, and it was also the second nation, after the USA, to operate a rover on Mars, so they bring solid credentials to the table. Here's the breakdown. In 2028, a mission to Mars will collect samples of Martian soil and rocks for immediate return to Earth. This is a known plan, but it's good to see it still on track. If successful, it will be the first ever Mars sample return mission. In 2029, another mission will explore Jupiter and its moon Callisto. This mission is interesting because it will join other probes studying Jupiter's moons, providing close-up studies for 3 of the 4 large Jovian moons, leaving Io as the odd one out. In 2030, China calls for the development of a large ground-based habitat to simulate long-duration human spaceflight, essentially a Mars and Moon base simulator. By 2033, a mission to Venus will return samples of the atmosphere to Earth. This is a bold idea, depending on how deep into the atmosphere the probe goes. It could involve a glide vehicle or a balloon to collect gas before returning to orbit. This is the first serious proposal for a Venus sample return. By 2038, an autonomous Mars research station will be established to study in situ resource utilization, essentially a robotic Mars base. This would be similar to China's planned International Lunar Research Station, laying the groundwork for long-term human exploration. In 2039, a mission will target Neptune's largest moon, Triton, including a subsurface explorer for its suspected ocean. Like Europa, Triton may have an icy shell covering a saltwater ocean, but the thickness of the shell is unknown. Drilling or melting through it to deploy a submarine would be highly ambitious, especially given the mass constraints of deep space missions. By 2039, we could unlock a much more efficient propulsion system, potentially something nuclear-powered, which isn't too far-fetched. This roadmap will be watched with great interest in the coming years. The timing coincides with a period of uncertainty for NASA, which faces potential budget cuts, lacks a confirmed leader, and has an Artemis program in trouble. Their Mars sample return mission is being reassembled with international and private sector support. Despite these challenges, NASA continues impressive exploration work on Mars, and a recent discovery by the Curiosity rover could be groundbreaking. Launched in 2011, Curiosity is the older of NASA's 2 active Mars rovers. It's a nuclear-powered, 6-wheeled robot about the size of a mid-sized car. Recently, it detected the largest organic molecules ever found on Mars inside a rock. Organic doesn't mean proof of life, just carbon-based molecules, which are the building blocks of life. These particular molecules are long-chain carbon structures, meaning they contain many linked atoms. On Earth, such complex molecules are often associated with biology. The Martian molecules could be fragments of fatty acids, which are found in cell membranes. If life ever existed on Mars, it was likely microbial, as the planet's harsh conditions probably didn't allow advanced life to evolve. However, microbes are hard to confirm, without more advanced instruments than a rover can carry, hence the need for sample return missions. The molecules Curiosity found consist of carbon chains bonded with hydrogen and oxygen. They come from a 3.7 billion-year-old rock named Cumberland, located in a dried-up lake bed inside Gale Crater. Scientists are especially interested in finding amino acids, the building blocks of proteins, but these long-chain hydrocarbons are still a major discovery. Among the detected molecules was decane, 10 carbon atoms, 22 hydrogen atoms, and naphthodecane, 12 carbon atoms, 26 hydrogen atoms, both part of a group called alkanes. These findings drive future Mars exploration, including China's planned missions. Meanwhile, the European Space Agency, ESA, is preparing its own major Mars effort. ExoMars. ExoMars represents Europe's third attempt to land successfully on Mars. In 2016, the Schiaparelli's lander crashed due to a computer glitch, and in 2003, the Beagle 2 lander reached the surface but failed to deploy its solar panels, losing contact. With $1.3 billion invested and 2 decades of development, there's immense pressure for ExoMars to succeed. Originally set for a 2011 launch on a Russian Soyuz rocket, the mission has undergone multiple revisions with shifting international partnerships. At one point, it was a major collaboration with Russia, but that's no longer the case. Despite these hurdles, there is still optimism. It has recently been announced that the French aircraft maker Airbus will replace the Russians as the builders of the ExoMars landing platform. The landing platform is a crucial part of the ExoMars spacecraft, responsible for the final descent phase to the Martian surface. Once landed, it will deploy ramps to allow the ExoMars rover, named Rosalind Franklin, to roll out onto the terrain. Currently, ESA is relying on NASA for launch support after the fallout with Russia, which forced the mission to abandon plans for a Proton rocket. NASA has agreed to provide a rocket, an adjustable thrust engine for the descent module, and radioactive heating units. The exact rocket has not yet been decided, but ExoMars is large enough that it will require a heavy lift vehicle like a Falcon Heavy, ULA Vulcan, or Blue Origin's New Glenn. The mission is tentatively scheduled for launch in December 2028, unless another option, such as a fleet of starships, becomes available. In other spaceflight news, the European aerospace company, ISAR, recently launched its debut rocket Spectrum, though the flight ended in failure. ISAR, a small space startup developing a small satellite launcher since the mid-2010s, aimed to provide Europe with independent access to orbit from the Andøya spaceport in Norway. After years of preparation and receiving approval last month, the launch marked the first orbital attempt from mainland Europe outside of Russia and the first use of Andøya as a spaceport. However, about 30 seconds into flight, the rocket encountered trouble during a planned pitch-over maneuver to gain horizontal velocity. Instead, it began wobbling, flipped around, and plummeted back toward the Norwegian island. The engines gimbaled in an attempt to stabilize the rocket, but the flight termination system was activated, shutting down its 9 Aquila engines and causing the vehicle to crash into nearby icy waters in a fiery explosion. The company later clarified that the termination system was triggered in response to the unstable flight, though no specific cause for the loss of control was given. Unlike typical flight termination systems that destroy the rocket, this one simply shut down the engines, allowing the vehicle to fall back intact, an unusual outcome for such failures. Despite the disappointment, ESA considered the launch a success due to the valuable data collected and the fact that the launch pad remained undamaged, allowing for rapid return to testing. Meanwhile, NASA's Perseverance rover continues its hunt for ancient microbial life in Mars' Jezero crater, recently caching its 24th sample, a tube filled with sedimentary rock that may preserve traces of past habitable environments. The rover's companion, the Ingenuity helicopter, has defied expectations by completing over 70 flights. Despite initial predictions, it would survive just 5. This tiny rotorcraft has become an indispensable scout, mapping terrain too risky for Perseverance to traverse. Back on Earth, private space stations are rapidly moving from concept to reality. Axiom Space recently unveiled the first module of its commercial station, set to launch and dock with the ISS in 2026 before eventually operating independently. Meanwhile, Sierra Space successfully tested its inflatable life habitat to pressures far exceeding requirements, proving the viability of expandable space structures. These developments signal a coming shift where government agencies become tenants rather than operators of orbital outposts. In propulsion breakthroughs, NASA's Advanced Electric Propulsion System, AEPS, completed qualification testing, marking a major step toward powering the Lunar Gateway. These solar electric thrusters, 10 times more efficient than chemical rockets, will enable sustained operations in cislunar space. Simultaneously, startup Xeno Power demonstrated its radioisotope power system using strontium-90, offering a safer alternative to traditional plutonium-based units for deep space missions. The race to return humans to the Moon saw significant developments as Blue Origin's New Glenn rocket completed stacking at Cape Canaveral ahead of its debut launch. Meanwhile, China conducted hot fire tests of its new 500-ton thrust Methalox engines for the Long March 9 Super Heavy rocket, while SpaceX achieved a record 48-hour turnaround between Starship launches. These competing programs highlight the intensifying global competition in deep space exploration. Perhaps most intriguingly, astronomers using the James Webb Space Telescope detected potential signs of life on exoplanet K2-18b, including dimethyl sulfide, a compound on Earth only produced by biological processes. While far from conclusive, this finding has energized plans for next-generation observatories like the Habitable Worlds Observatory that could provide definitive answers about life beyond our solar system within the next decade. As these parallel developments unfold, the space sector appears poised for its most transformative decade since the Apollo era. With robotic explorers rewriting our understanding of the solar system, while new technologies and commercial players redefine how humans access and utilize space. Each mission and technological leap brings us closer to answering fundamental questions about our place in the cosmos while laying practical foundations for a multiplanetary future. The lunar exploration landscape is heating up as multiple nations race to establish permanent outposts. India's Chandrayaan-4 mission, scheduled for late 2025, aims to demonstrate critical technologies for lunar resource utilization, including a prototype oxygen extraction system. Meanwhile, Japan's Slim lander, which recently survived its second lunar night, despite not being designed for such endurance, continues to send back valuable data about the Moon's surface composition. In a surprising development, analysis of data from NASA's retired Spitzer Space Telescope has revealed unusual thermal signatures from several asteroids in the main belt. These findings suggest possible volcanic activity or outgassing events, challenging our understanding of small-body geology. The upcoming Janus mission, set to launch in 2026, will investigate these phenomena up close, using a pair of identical spacecraft to study binary asteroid systems. The field of in-space manufacturing is reaching new milestones as Varda Space Industries successfully returned its first batch of space-grown pharmaceuticals to Earth. Their innovative re-entry capsule delivered crystallized proteins that are impossible to produce under terrestrial gravity conditions, potentially revolutionizing drug development. Several pharmaceutical giants have already signed contracts for future production runs. On the propulsion frontier, NASA's pulsed plasma rocket concept has achieved breakthrough results in laboratory tests, with specific impulses exceeding 5,000 seconds. This technology could theoretically enable crewed missions to Mars in just 2 months, compared to conventional 6 to 9 month transit times. DARPA is collaborating with private partners to develop a prototype for ground testing within 3 years. The search for extraterrestrial intelligence has entered a new era, with the recent activation of the Square Kilometre Array's first operational stations in Australia. This massive radio telescope array, when completed, will be sensitive enough to detect airport radar-level transmissions from planets orbiting the nearest stars. Breakthrough. Listen has already begun reanalyzing archival data using new machine learning algorithms that recently identified several previously overlooked narrowband signals worthy of follow-up. Meanwhile, in low Earth orbit, the first operational tests of satellite servicing technologies are underway. Northrop Grumman's mission extension, Vehicle 3 has successfully docked with an aging communications satellite to provide propulsion and attitude control, potentially extending its operational life by 5 years. This demonstration could mark the beginning of a new era in orbital sustainability and debris mitigation. These developments, across multiple space sectors, demonstrate how rapidly capabilities are advancing, with each breakthrough opening new possibilities for exploration, science, and commercial applications. The coming years promise to deliver even more dramatic progress as these technologies mature and converge. The asteroid mining industry is quietly making strides as 2 competing startups recently demonstrated key technologies. Astroforge successfully tested its zero-gravity ore processing system aboard the ISS, while Transastra's orbital refinery prototype completed its first simulated extraction of platinum group metals from asteroid-like material. These advancements come as Luxembourg becomes the first nation to establish a legal framework for commercial space resource rights, potentially triggering a new gold rush beyond Earth. In propulsion breakthroughs, MIT researchers have achieved sustained fusion containment using a revolutionary compact tokamak design, potentially paving the way for practical fusion-powered spacecraft within 2 decades. Meanwhile, a European consortium has begun testing an air-breathing electric propulsion system that could allow satellites to operate indefinitely in very low Earth orbit by harvesting atmospheric molecules for propellant. The search for life in our solar system has taken an intriguing turn with the discovery of vast underground brine reservoirs beneath Mars Valles Marineris, detected using novel quantum gravity sensors aboard ESA's ExoMars TGO orbiter. These liquid water pockets, kept from freezing by high concentrations of perchlorate salts, may represent the most promising locations to search for extant Martian microbes. NASA is fast-tracking development of a deep, penetrating cryobot probe to explore similar environments. Space weather prediction is entering a new era with the launch of NOAA's first operational Lagrange 1 space weather satellite, providing continuous monitoring of solar activity with unprecedented resolution. This comes just in time as we approach the solar maximum of Cycle 25, which has already produced several X-class flares that narrowly missed Earth. New AI models can now predict dangerous solar storms with 90% accuracy up to 48 hours in advance. The commercial space station race is intensifying as Voyager Space's Starlab project selected SpaceX's Starship for a single launch deployment in 2028, while Orbital Reef has begun manufacturing its core modules using in-space 3D printing technology. These developments coincide with NASA's announcement of a new $1.8 billion fund to support commercial LEO destinations as the ISS approaches retirement. Perhaps most remarkably, astronomers using gravitational wave detectors have identified what appears to be an intermediate mass black hole wandering through our galactic neighborhood just 2,000 light-years away. This rogue object, detected through its microlensing effects on background stars, could provide the first opportunity to study such enigmatic objects up close if follow-up observations confirm its nature and trajectory. These rapid advancements across all facets of space exploration and utilization demonstrate how we're entering an era where science fiction concepts are becoming operational realities. Each week brings new breakthroughs that were unimaginable just a decade ago, setting the stage for what promises to be the most transformative period in humanity's relationship with space since the dawn of the space age. The space industry is witnessing an unprecedented surge in debris removal technologies following a near-catastrophic collision event in low Earth orbit last month. Startups like Astroscale and ClearSpace have accelerated testing of their capture systems after a defunct satellite came within 20 meters of an active communications platform. New regulations requiring post-mission disposal have created a $3 billion market for active debris removal services, with the first commercial cleanup mission scheduled for early 2025. Quantum communications took a giant leap forward as China's MISIUS satellite network successfully established the first intercontinental quantum encrypted video call between Beijing and Madrid. This unhackable communication technology, leveraging quantum entanglement principles, is being rapidly adopted by financial institutions and government agencies. The European Space Agency has fast-tracked its own quantum satellite constellation, with the first launch planned for late 2024. Lunar infrastructure development reached a milestone as NASA's Artemis program